the first thing we're looking at is the empirical rule, okay? Does anyone in class know the empirical rule? Off by heart at this point in time. Okay, what is the empirical rule, right? So, huh?
The 68.
68%, the 90%, and the 99.7% rule. Okay? So this will be in your statistics notes I would have handed out recently. Give me 1 second. Oh, I see. So, this is the only thing. Manufactured light bulbs, after tested 10,000 of a particular brand of light bulb, it was determined that the lifetime of these bulbs is normally distributed. Normal distribution means it looks something like that. Okay. Has a mean. Mean means dead center. The average is 750. Everybody cool with that?
Yeah.
Now, standard deviation is 60. Please remember in your leaving cert, standard deviation, you only need to know how to use your calculator. Okay, just remember that. And then use the empirical rule to find out what lifetime interval. What's an interval? The word interval, what does that mean? Huh? It means in between two values. A lower value and an upper value. So what values are the in between? Now, the word 95% is a learn off by heart. It means 2 standard deviations above and 2 standard deviations below. Has anybody found that page in the notes? Yeah. Sam showed me there with it. That page there. That's the one you're looking for, okay? Okay, just flick. Okay, grand. So, we're going to do 2 standard deviations above, 2 standard deviations below. 2 standard deviations would be 120. Is everybody happy with that? Take it away and add it on. Take it away, you get 630. Add it on, you get 870. So it's 630 all the way to 870. Is that okay?
Yes.
Empirical rule, got no off by heart. Now, this one was the one I gave you notes on. Not in here, but I gave you handouts when we did it in class, okay? So I really want you to remember this one. This is what's called hypothesis testing, okay? Now, hypothesis testing is done the following. A recent newspaper had the following headline. Less than 30% of primary school students walk to school on a regular basis. A group of students carried out a survey of primary schools in their local area. They found out 270 out of 860. Now, 270 out of 860, what fraction, what percentage would that be? 270 over 860 is what we got. Divided by 860. And we, as Dennis said, 31.4%. Everybody happy enough with that? Okay, so, or basically 0.314. Now, use the hypothesis test at the 5% level of significance. You only have one type of hypothesis test in your course. Okay? Therefore, what it says doesn't matter once it says hypothesis test. Now, what you have to write down for hypothesis testing, does anybody remember? The null and the alternate hypothesis. Okay? H0 means nothing has changed. H1 means your old statistic has changed. So, to find out what H0 is, it's always the one they claim it is in the question. They say 30%, less than 30% of students walk to school on a regular basis. Is that alright? So that's what you write down is that H0 is less than 30% of primary school children. You just rewrite what's there. Walk to school. Okay. Now, what's the alternate hypothesis? What's the opposite to less than 30%? More than 30%. Or less than 30% of primary schools do not walk to school. Just something that's exactly the opposite. You got that? So, does everybody understand I'm going to use exactly the same language all the way across, yeah? It's the same thing, except more than as opposed to less than. Now, what we have to conclusively figure out is, we currently think, look, it's definitely more than, isn't it? Yeah. Definitely more than, but what's the problem? Can anybody remember the problem? Margin of error. Error. Margin of error. Okay? 1 over the square root of n. What does n stand for again? The sample size. So can anybody tell me something? The bigger the sample size, the smaller the margin of error. Okay? So as an example, I want to show you something. 1 over the square root of 180, okay? 1 divided by root 860 is a 3.4% margin of error. Does everybody see that? Now 3.4 or 0.034. However, if you raise that to 86,000, as in you, or 86,000, you interviewed a load of people. What happens to the margin of error? That's a really, really small number. That's 0.0003. So that's a really small number. Long story short, the more people you interview, the smaller your margin of error. Now, back to our question. We have a 0.034 margin of error. Would you agree with that? This means the result that we think is 31.4% could actually be anywhere in between what two values? You always add it on and take it away. So it's going to be take away this green number from the purple number, and you get two statistics. Okay, you get 0.28, and we'll call this a p-value. Okay, because it's just like a proportion value. Less than, and then add it on 0.3. What's it? 348. All of a sudden, this 30% that we're looking to check, is 30% within this limit? Is 30% in this interval?
Yes.
It is. So therefore, nothing has changed. Okay. So therefore, what we say is we accept H0. Is that okay?
Yeah.
I have a good feeling this might happen. There's something about it. I just have a good feeling. I was at an in-service over the weekend and they really stressed this. So they were stressing and they highlighted they can't be asked this. So obviously, I have a good feeling about this one. So just. Oh, it's the only one I have a feeling about. Everything else I don't. Okay.
Good thing it's recorded.
Yeah. Now, I'm just going to move on to a bit of geometry. Okay. Slope formula, guys. Everybody's familiar with slope formula, right? Line AC. I hope the God you are. y2 minus y1 over x2 minus x1. Put it into the calculator. I need somebody on the calculator for me. Get this done very quickly. Okay. x2 y2, x1 y1. Okay. 7 minus 1 minus 4 minus 3. Okay, anybody on that?
No.
I'm getting minus 6. You guys double check that for me.
Minus 6.
Okay. Now, stay whether or not BC and AC are perpendicular to each other. Lads, what's the test for perpendicular lines in this? Once again, not in your notes.
Slope.
If you multiply both slopes by each other, they have to equal minus 1. Okay. I know the slope of AC, which I'm going to colour in green. I need to know the slope of BC. How do I get the slope of BC? Do I know 2 points on BC? No, but what do I know about BC?
C.
I know the equation of the line. I also know C. You're right, but that's only 1 point. I need 2 points to work the slope formula. So, when you're given the equation of a line, guys, is it possible to find the slope of a line just by having the equation of the line?
Yes.
How? It's in your tables. Y equals mx plus c. Okay. So if you get y isolated on its own, whatever number comes in front of the x side is the slope, and whichever value is beside that is where that line crosses the y axis. Yes.
When do you know whether to use that line?
Either I have 2 points on a line and I can find the slope, and if I don't have 2 points and I'm given the equation of the line, then I can use y equals mx plus c.
Okay.
Right? Get y on its own. 4x minus 9 equals 3y. 3y equals 4x minus 9. Divide both sides by 3. 4 over 3x minus 3. Now, are they perpendicular to each other? What's the slope of this one? What's the slope? Is 4 over 3 perpendicular to minus 6?
No.
Because when you multiply them, it's going to be minus 12. And it should be minus 1. It's not minus 1, therefore they're not perpendicular. Ever read that? Yeah. Okay. BC intersects the y-axis at point B. Find the coordinates of B. What is guaranteed about the y-axis? Every point on the y-axis, what's guaranteed? X got to equal 0. What are they talking about? They're talking about B to C. B to C is that one there. 4x minus 3y minus 9 equals 0. So what should I do? Coordinates. You want an x value and a y value. We know the x value has to be 0. We find the y value. So it's going to be 4 times 0 minus 3y minus 9 equals 0. Minus 3y equals 9. Y equals minus 3.
Why does the x value have to be 0?
Because on the y-axis, the x value is always 0, no matter what point you pick. Likewise, on the x-axis, the y value always has to be equal to 0, no matter what's going on. Okay? Find the area of the triangle ABC. So let's go back to our diagram again. 0 minus 3. Okay. That's 0 minus 3, is it? Okay. So lads, stop that for a sec, guys. Okay, 0 minus 3. What's the C value again? Just give us point C. 3, 1. Does it give me the B value? Just tell me what B is. Oh, sorry, 0 minus 3 is the other one. 0 minus 3. It's that one there. And I'm looking for the triangle ABC. Do I know what A is? Minus 4, 7. Okay. That's the picture I have here, and this is a very important formula for you guys to use. You have 3 points, and you need to find the area of the full triangle. Has anybody have an idea what we can use to sort that out? Area of a triangle.
Yeah, but could you get the length of the...
You could get the length of all 3 and do the S formula. S equals A plus B plus C over 2. There's a much more convenient coordinate geometry way of doing it. Anybody remember? Okay, good, we're doing this so. It's the formula A equals a half the modulus of x1 y2 minus x2 y1. Does anyone in the class remember the catch for using this formula? There's a catch to it though. What? One of the points has to be 0, 0. Okay, none of the points are currently 0, 0. Can anybody suggest a method for changing that? Huh? Translate it to the origin. What that basically means is bring the nearest point to the origin and make a new triangle that's exactly the same size as the old triangle, but has same area but different points, but it's still the same area as the old one. So my suggestion would be just to up the B value, up this one to 0, 0. So I'm going to turn 0 minus 3 into 0, 0. How did I do that? Add 3 to y. So add 3 to that one. Huh? Minus 4, 10. And then add 3 to 3, 1. And you get 3, 4. Now you have 3 points. How many points can this formula take? And why? How many points can that formula actually take? How do you know that? x1 and x2. That means 2 points. If there was an x1, x2 and x3 there, it could take 3 points. But it can only take 2 points. Out of my choices here, yellow, and purple. Which two should I choose and why? Yellow and purple, why? You never choose 0, 0. That's I know. You always put one of them as 0, 0, and you choose the other two for your formula. Try not to completely contradict myself. Now, with my language, I need to be more careful. Now, what you do is you just put it in blank like this. Does anyone remember what those two lines mean? The two big lines. And what does that mean? Never be negative. So as an example, the modulus of -5 is 5. Okay? And there's actually a button for that in your calculator as well. You'll see a modulus, two straight lines and a block in between. I'm trying to find it now. Modulus.
The abs.
Where?
The abs.
Abs. Yes. The absolute value. So if I put a -5 here, what happens? Gives you +5. Okay? So we've got to work on the abs. Now, that's x1, y1, x2, y2. Ready? -4, y2, 4. Minus x2, y1, 3, y1 being, what is y1? 10. Okay. A half of, what's that, -16 minus 30? -16 minus 30 minus 46. A half the modulus of minus 46? Plus 23, plus 23. So, a half adds 46, minus 46, sorry. And if you want, gives you plus 23. There we go with that? Okay. Construct a triangle. I'm just going to show you roughly what a construction question turns up as. This is in your new notes, so if you go to the constructions at the end, you'll see constructing triangles. Okay, anybody who does TV should do this in their sleep. Okay, so I gotta calibrate this. I gotta construct a triangle with 3 pieces of side information. So I'm going to do a 12 centimeter long start off point, and that will give me A to C. Okay, then I take out my compass, and all the marks go towards the construction lines. I then have to find the point B. The point B is 5 centimeters away from A, which will be that end there. So I draw an arc to represent the 5 centimeters. Then I twirl this around, and then I have to draw a 12 centimeter length to AB. And that's going to, 13 centimeter length. Unfortunately, I don't know if I made my compass long enough. Hey, that's great. Okay, let's go back to the start. So, that won't happen to you. That happens to me.
This is the website.
I really can't actually. Yes, Dennis, what?
Does it say you have to construct a triangle?
That's exactly what I'm doing, Dennis. Just give me a second. I said I made a mistake, so I'm fixing it.
I don't see any triangles. He's trying to draw.
Ready, guys? So here we go. 12 centimeters on the first, 13 centimeters, I'm going to do A to B for a section. So I'll do 13 centimeters from A to B, like so. That's 13 centimeters on my new ruler, which is A to B. Have to find point C. C is 12 centimeters away from A. So being 12 centimeters away from A, I got to then get 12 centimeters here, create the arc, just about got that, 12 centimeters away. So this line represents any points that are 12 centimeters away from A. Any point on that line is 12 centimeters away from A, guaranteed. Next thing I got to do is I got to do 5 centimeters away from B, because BC is 5. Okay? So go here, there's a 5. Or roughly 5, being a bit temperamental. There we go. Then go to B. Now guys, we're a couple of cheap marks. Oh. Waiting on that, were we? Oh god. Often you won't make the arc big enough, or if you're me, you won't make the arc big enough nearly the majority of the time. So you gotta go back and go back where you came from, and then make a bigger arc. Then you just link them up together, and you get your right angle your triangle. Now, the next question is an interesting one. The next question is basically asking me, write down a statement that will show that this is in fact a right angle triangle. Anybody know what's the only conclusive way, one of the only ways of proving that a triangle is definitely right angled? Anybody remember? Pythagoras' theorem has to work. Has to work. If it doesn't work, it's not right angled. So what you write down is, I'm going to use Pythagoras' theorem to prove that this is right angled. The longest side squared equals your two sides squared and added together. 169 will equal 169. That's what happens when you use the calculator. Because Pythagoras' theorem works, it guarantees that the triangle in question is right angled. Everybody cool with that? Anything you didn't know?
Put it in a circle and made 13 the diameter.
You could try putting in a circle and saying that if I drew a circle around this using that as its midpoint, and all 3 points are on that circle, then you could say it's a right angle because the diameter is. Yeah, that's another way. You could try it that way. Yeah. Pythagoras' theorem would be the go-to there, though, I'd say. Okay, lads. Now this one's, remember the congruent triangles? Yeah? Okay, this is the type of level I think that will come up in this one. Now, predominantly said that you're just going to be looking for targeting and account marks in these, which is the truth. But we'll work with it anyway. Mark out what CAD is. CAD is this one here. Okay. DCA. Okay, so what they want me to do is they want me to prove that CAD equals ADC. They want me to prove that that green one there is equal to that green one there. Okay, just double check that. A to D to C and C to A to D. I want to prove the two green ones are exactly the same. You just want to try and get as much attempt marks as you can here, right? And then hopefully get it out. It just doesn't appear to you. You got to do a lot of work on it. So what I've had you guys remembering off by heart is CX factor. These are alternate angles. These are vertically opposite angles. And finally the F is corresponding angles. And we're going to try and use some sort of combination of them to find an answer. Now what does it give us? AD bisects CA. B. That means that one there equals that one there. Everybody cool with that?
Yeah.
Alright. Then we know blue will equal blue, don't we?
Yeah.
Vertically opposite. Okay.
Should that A not equal the one on the other side?
Sorry?
Should the A not be on the other side of the line? Yeah, that's what I'm
CAD.
saying. No, the angle at A, should that not be on the other side of the line?
C to A to D. No. CAD is the green one. That one there you're talking about. This one.
Yeah, the green one, yeah.
Yeah, C to A to D. No, it shouldn't be on the other side.
That uses that then.
No, the one you're using, you have used that one there.
Yeah.
That angle is DAB.
Yeah. Could you use that for the Z?
For Z. Oh yeah. I'll do that in a second. I haven't even got there yet.
Right.
Yes,
so
Dennis.
you see how the red one's connected? Shouldn't the blue one be connected like that as well? Because they're the same.
No, I'm reading the question, Dennis. It says CAB, which is it says DCA, D to C to A. That's the full red angle, only because it says it. Okay.
Oh, right.
Now it says DCA gets bisected, right? And because it gets bisected, it means those two angles, if you split the red angle in half, they're actually exactly the same as each other. Everybody cool with that? Now, does it say anything about parallel? It says AB is parallel to CD. that brings Sam's theory into play. That Sam's locking on that this green one here is the same as that green one down there. You happy enough with that? And it also might bring into play that this red one up here is the same as that red one down there. Okay. Now, what we weren't guaranteed at the start was we're trying to prove that CAD is the same as ADC. So, what we haven't, I can now use all my triangles combined because they're all similar triangles now, aren't they? And I can say, where's the other one there? Red, blue, green. Red, blue, green. Okay. So we want to prove that this one here is CAD is the same as A to D to C. Okay. Now let me see. Blue, red, green, blue, red, green. Two down are alternate. I'm just trying to see how to wrap this up. That's the same as that one. A second. Next thing then is I never used AD bisect CAB. So this means that this angle here equals this angle here. And now I finally proved that C to A to D is the same thing as ADC. Now how do you write that down in the language you're looking for? Like, what did we actually use to make this happen? Well, we're going to have to write down everything formally, so I'll just get rid of that one for a second. Let's start off with what we know. Let's start off with the red section. The red section reads, would everybody agree that ACP, or ACB even, ACP equals angle DCP. That's the red section explained, yeah? And it's given, right? Now what about the green angles? The green angle, I'm just going to mark it in yellow, that green angle there and that green angle there. What do we do for the two of them? What's the reason behind that? Which is also known as a what? So CDP, is that they want it as they want that as ADC, sorry, so ADC. So that's the angle ADC, and it equals the other one, the other yellow one, for what reason? DAB for what reason, guys? It's alternate angles, isn't it? It's the Z. This is referring to the two yellow angles. Yeah? They're the same because they're alternate. Now, the next part after that is referring to the second part of green ones. It's referring to the two green dots. Why are they the same as each other? Because it's given, isn't it? It's given, it's bisected. So that means that DA, what way does it wants it as CAD, because it says it in the question as CAD. So CAD equals, what way did we write the other one again? DA. Big bisected angle. Now what did we want to prove at the end of the day? CAD equals, and we're pretty much there. CAD equals ADC. Just try and make an attempt at it. Now imagine that you didn't really do too well there. How would you pick up some of the 10 marks in the next one without doing much? How would you get yourself on 4 out of 10? Anybody? 4 out of 10 without even thinking much? SAS, ASA, and SSS. One of them's got to be right, so you count out the 10 marks. Okay? It says the word congruent. Now, I want to prove that APC and PDC are congruent. APC, A to P to C is the one on the left, and what's the other one? P to D to C. So I'm just going to mark them off in different highlighters here. I use blue for this one. that one there, yeah? And I wanted to make sure that it's the same as APC, which is this one here. Okay, now, okay, we're hardly going to use SSS. They're not right angled, so I can't use RHS, can I? So RHS is gone. Does it say anything about tree lengths? Does it say anything about something being the middle of the other thing? It doesn't guarantee that P is the middle, does it? No, so we're not looking too good on the length front at the moment. Okay, and then do they have a common side?
So doesn't P have to be in the middle because C is bisected? If it bisects C,
It's bisecting the angle facing that side, so it would be the middle. Yeah, good call. So this one here, see that point there, guys? You're asking why is it at the middle? If you have any regular triangle, okay, and when you have a regular triangle, once again, lots of good learning here. When you have any triangle and you bisect one of the angles, so you have this here, and you cut this angle in half. If that's cut in half, what it does is it bisects it cuts in half the other side. Is that alright? So what we can say now is that, and to be honest, we actually didn't need that anyway, believe it or not, but you're right. But see the way they have a shared side? They share that side, don't they?
Yeah.
So it wasn't needed anyway, but it's a good call. So we'll start off with CP equals CP. That's the really easy way of doing this. So to prove that triangles are congruent, you target both triangles in question. You write three lines for congruent as opposed to equals, okay? That's in your notes as well. Let's start off with easy money here. PC equals PC, because it's in both of them. It's common. Okay? Because we can only prove one side, what are we definitely going to use? What's the only choice if we can only prove one side? ASA. It's the only choice we have, because we only have one side. So what I gotta do next is I gotta prove that I want to prove that that's a purple angle, and I have to prove that that's the same as blue. Okay, that's gonna be interesting. Okay, it's grand. Now this one here, angle C. I'm going to prove ASA. To prove ASA, I want to target that angle, that side. That angle, that side. I basically have to get the side and two angles like that to prove that they're the same thing, right? Now we already know two of them, okay? We already know, I'm just going to rub this back out again. I already know that this one is the same as that one. Why is that? Yeah, so it's given. So angle ACP equals PCD. And the reason is bisected. Bisected angle ACD. Now, the only other angle I have to prove now is that these two equal each other. I have to prove that that one equals that one. Any reason why? Well, because CDP is the same angle as BAC, all three angles add up to 180, therefore the other two angles have to be the same amount. Okay, so what you can say there is, just in the side you can say, because, what's the green angle again? The green angle is CAP. Because CAP equals CDP, this implies, that means three dots, implies that what we're looking for, implies that CPA, implies angle CPA is congruent to angle CPD. And then you got your ASA. Once again, guys, it's very difficult stuff. Just write down your combos, make an attempt, see where you get, pick up most of the marks, okay? Now, this question was very good. This question was really good, okay? Now, what they really do to you in these questions is to really fill you up with a lot of junk, so to speak. Has anybody done this question yet? The pennyfarthing question? Okay, you would have had it on your 2015 revision, but obviously didn't get done. Okay, so let's see what's going on here. La, 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 la. La, 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 la. I'm even reading that. Okay, that is how much extra reading they gave me that was irrelevant. They gave me no numbers, they gave me nothing about it. Just, it's a big wheel and a small wheel, it's a pennyfarthing bike, right? All that can disappear. Now, it has a diameter of 120, now 1.2. I'm going to convert that straight away into centimetres, because I'd like it to be the same as the other one. Therefore, it has a radius of 60. The other one has a radius of 21. Find the circumference of the front wheel being the big one. Circumference formula? (120 pi). Is that right?
So is there 1,000 centimeters in a meter here?
No, 100.
Oh,
Now, if the cyclist pedals the bicycle such that the front wheel rotates 2 revolutions per second, calculate the speed of the cyclist in meters per second. To get attempt marks even, what's the formula for speed? It's not in your notes. It's not in your tables. Distance over time. Okay. Now, every single time you rotate like that, you basically, when you spin, you cover the distance of the circumference. Would you agree with that? So how much distance did we cover if we do, how much distance per second did we cover if we do 2 rotations per second? It says it there, 2 revolutions per second is 2 rotations a second. 1 rotation is 120 pi. So, now, one problem, it wants it in meters per second, doesn't it?
yes.
So I might just convert that back to, 0.6. 2 times 0.6 is 1.2 pi, is that alright? Or just divide the last answer by 100. So distance is going to be 2 times 1.2 pi. That's how much distance I cover in 2 revolutions. And the time, that's only in 1 second, isn't it? So 1 second, not 15, 1 second. That makes that 2.4 pi per second. I'll change it to decimals now. 2 bracket 2 1.2 pi. 7.54 meters per second. Is that okay? So this goes from 7.54 meters per second. Everybody alright with that? Okay. The rear wheel travels at the same speed as the rest of the bicycle, but it has to rotate faster. Would everybody agree it has to rotate a lot faster? Find correct in 1 decimal place the number of revolutions per second at which the rear wheel rotates. Well, what we know is that the front wheel, the speed of the front wheel, everybody agree that the speed of the front wheel is actually 2.4 pi or 7.54 seconds, yeah? So the speed of the rear wheel is equal to distance divided by time. Now, it has to cover the same distance. The rear wheel has to cover a distance of 2.4 pi per second. Would you agree with that? What's the circumference of the smaller wheel though? It has a smaller radius, doesn't it?
2 pi 21.
Yeah, it has. So the circumference of the smaller wheel we'll call it L subscript S, is 2 pi r. So it covers 2 multiplied by pi multiplied by a radius of 0.21. So it's going to be, what's it, 0.42 pi? What?
What's the S?
It means the length of the smaller wheel. Okay? Now, the smaller wheel, which covers this much distance for one turn, has to cover this much distance in 1 second. How many revolutions is that going to be? How did you find that out? Divide it. Divide the big distance by the smaller distance. For those of you that are a bit lost, it's basically like me saying, I have to travel 10 meters in 1 second, but my small wheel will only cover 2 meters per revolution. This means my wheel is going to have to rotate 5 times in 1 second to cover that 10 meters up. Does that make sense now? That's basically what we're doing. Okay? So, we divide one by the other. Anybody know what we get there? The pi's cancel. 2.4 divided by 0.42? 5.7 rotations per second. To 1 decimal place. 5.7 rotations per second. Anybody have any questions on what we've done so far? Okay. Now, they recreate the full system as a geometry of a circle. So this has a lot of revision in there, okay? So what they're saying is, now, we have a bit of a geometry system, don't we here? Okay? If we call that 0, 0, what can I call this? Let's use centimeters. Anybody have any idea what I could call that?
1, 0.
How about 21, 21? Why am I calling it 21, 21? The radius is 21 centimeters. So 21 centimeters across, 21 centimeters up would give me 21, 21. Everybody alright with that? Okay. Huh? Because it says in the original question that the radius is 21.
Yeah.
So a circle, Dennis, is basically a circle. If you go across 21 and then you go up 21, you create a distance of 21 in that direction and a distance of 21 in that direction, and therefore a circle can appear that's 21, 21 away from the centre. Anybody get that, or we're good? Okay. So that's 21, 21. Okay? Happy enough with that. The big one, I'm not going to figure that one out just yet, because I can't exactly say it's 60, 60, can I? Why can I not say that's 60, 60?
Because it's 8 centimetre gap.
Because
It's not touching the axis, is it? It's not touching the x and y axis.
wait, which is it?
The big circle.
But it is. What
It is.
Oh no, but it's not touching the y axis.
Oh.
What is it there? Is the x not 61
I'd
20?
argue that
Oh, sorry, there's a
the
difference.
y value is definitely 60, but the x value, I haven't got a clue just yet, because I think it's more than 60 away from the axis.
The gap between the
Yeah, and there's another circle in there as well.
Yeah.
So I can tell you that the y coordinate is 60. How do I know the y coordinate is 60? Because it's a radius length away from the x-axis. It's not a radius length away from the y-axis. That means I can't call this one, cannot call that 60. Does that make sense? Okay, let's work on what we have. What is the common tangent to the two circles? What is a tangent?
It's where it hits the line of the circle.
Hits once. Is there a line that hits both of them once? Okay, the x-axis is the right answer. That's one answer. Can anybody give me a different way of representing the x-axis? Anybody know it? y equals 0 is a horizontal line. Y equals 2 would be a horizontal line going across at 2. Doesn't go up or down, just goes straight across. Is that alright? Can anybody give me a different name for the y-axis? X equals 0. Okay? Now, the distance between the, write down the centre of C1 and hence the equation of C1. The centre is 21, 21. What does it mean by equation of C? What type of equation are we dealing with there? Equation of a circle. Where did you find the equation of a circle formula in your notes? Tables. What page? I think it's 18 or 19. So geometry. But anyways, x minus h squared plus y minus k squared equals r squared. Okay, guys? Huh? It says find the equation of C1. C1's a circle. Therefore, what it's really asking you is find the equation of a circle. And that's the equation of circle formula. Lads, what's HK stand for? HK? The centre of the circle. Yeah. X minus 21 squared. Y minus 21 squared. What's the radius squared? Radius squared, anybody? What is the radius? 21. So 21 squared is 441. Now, there we go. The distance between the two circles C1 and C2 along the line joining their centres is 8 centimetres, as shown. Find the distance between the centres of C1 and C2. What it really wants me to do is it wants me to find, I'm just going to rub all this junk out for a minute. What it wants me to do is it wants me to find here to here. It wants to find that to that. I need this. Two radius added together plus the 8. So you get your 60 here, your 21 there, and your 8. And of course it turns into 69. Now, 60 plus 21 plus 8, 69 centimetres.
That is not 69. That is just.
Oh, that's 89.
Not even counted.
89, is it?
Yes.
Ah, there we go. 89 centimetres. Now, lads, next order of business is use protagonist theorem. You shouldn't even need to tell you that. Because find the horizontal distance x as shown in the diagram between the centres of C1 and C2. What I want you to look at is, we know that's 89 now. I want you to find out what is the distance x here. I have no angles. Is there any way I can get the green length here? Anybody have any ideas how to do that? 60 minus 21. Where did Paddy get that from? 60 minus 21. 21 from here to here. 60 from here to here. Still a 21 when you bring it across like a rectangle. That makes the other one 39. Okay. So what you got there is got there is Pythagoras' theorem. 89 squared equals 39 squared plus x squared. Oh, sorry. 89 squared equals 39 squared plus x squared. 89 squared minus 39 squared. 6,400. Square root of that will be 80. Are we cool with that? X equals 80. Yeah. Now, it then asks me to say, find the equation of C2. It wants me to find the equation of the big one. Okay? Well, the great news is, we now found out that if we rub all this out again, we found out that that's 80. Okay? We already agreed earlier on that the y value was 60. What is the x value?
81.
Not 81, but close. 101, because you have 21 across for your first radius, plus your 80 is 101. So we have 10160 with a radius of 60. 10160 radius equals 60. Once again, your x minus h squared plus your y minus k squared equals r squared. X minus 101 squared plus y minus 60 squared equals 3600, which is 60 squared. And that's your equation of your line there. Okay. Stop it there for a minute.